Hello and welcome to Maths with Jacob. This lesson will focus on indices and division. Following on from the previous lesson, which looked at indices and multiplication, we now look at indices and division. With multiplication we had two examples here. M squared multiplied by m to the power of 3 was m to the power of 5. We saw that when we had this situation where the bases are the same, we just add the indices. Likewise, when we had this situation, we multiply the coefficients, 3 5s are 15, and because the bases are the same, we add the indices. In multiplication, we saw that we need to add the indices when the bases were the same. For subtraction, the following rule applies, and this is the rule. If you divide two or more terms that have the same bases, keep the bases the same and subtract the indices. So, using letters we have a to the m divided by a to the n. We keep the same base, which is a, and we subtract the indices m minus n. This is a general formula, and that applies to all examples. This is a very important note. For all future lessons, we will refer to the letters we use in all our algebra work as pronumerals. This is a very important word. These pronumerals take the place of numerals. So basically, whenever you see the word algebra, that is closely linked to the word pronumerals. Let's have a look at some examples. Simplify each of the following using the appropriate index laws. A to the power of 5 divided by a squared. There's our base, and we subtract the indices. 5 minus 2 is 3, so the answer is a to the power of 3. 10m to the power of 7 divided by 2m to the power of 3. We divide the coefficients. Remember, they're numbers that come at the beginning of the terms. 10 divided by 2 is 5. However, for the indices, we subtract the indices because of division. So that's 4, and the base is the same. Next example is similar. 15 divided by 3 is 5. We have a to the 6th and a squared. 6 minus 2, that gives you a to the power of 4. Y to the power of 8 and y to the power of 5. 8 minus 5 is y to the power of 3. Number 4. With this one here, we have 3 pronumerals there and 3 here. 20 divided by 2 is 10. K to the 9th divided by k cubed is k to the power of 6. Y to the 7th divided by y squared is y to the power of 5. And h to the 8th divided by h to the 6th is h squared. So in each case, we've subtracted the indices. Next example, very similar. 24 divided by 3 gives us 8. M to the 8th divided by m squared is m to the power of 6. W to the 9th divided by w to the power of 5 is w to the power of 4. And k to the 7th divided by k squared is k to the power of 5. So, we can also perform these calculations in a slightly different way. This is just another way of doing it, just to give you another option. And it doesn't matter which method you use, as long as you get the answer, both of these are acceptable. So w to the power of 5 divided by w squared can be written this way. W to the power of 5, that's what that means. W squared, that's what that means. So all you do, you cancel the same number of w's from the top and bottom. Because there are a w there and a w there, we cancel those two and we cancel the same number from there. And what are we left with? W cubed. That's just a multiplication sign there, that doesn't count. So we're left with w cubed. Very similar here. You can do it the normal way, like we did here, or there's another option. 8m to the power of 5, that's there. 2m cubed is there. You cancel 3 m's from there and another 3 from there. 2 into 2 goes once. 2 into 8 goes 4. So the answer is 4m squared. And there it is there. So this video has presented a lesson on indices and division. So when we're dividing terms together, that is algebraic terms together, and there are indices involved, the important rule is you subtract the indices. But the coefficients, which are numbers at the beginning of the terms, they can be divided together.